Excuse me, miss, what are you doing here?
Well, you see, I was here with the other construction workers, and I'm trying to measure the angle of this bridge.
Were you trying to measure that in degrees or radians?
Radians? What's that?
I think I have a rap that'll help you figure that out. This is WAN Collective, 2K15.
3.0.
Junior year, pre-calculus, circles and radians. Get some. Let's go. Degrees are super fly, but radians, they make me want to cry. What are all these numbers and values of pi? Stick with us and we'll see what they're divisible by. Degrees are super fly, but radians, they make me want to cry. What are all these numbers and values of pi? Stick with us and we'll see what they're divisible by. Let's start with angles. They measure the amount of turn. They're measured in degrees, or at least that's how we learned. But now we're in pre-cal and talking radians. What does that mean? It's the angle created when you take the radius and you wrap it along the edge of a circle. It's a struggle to rhyme, yeah, I know, but with definitions as long as this, yeah, that's just how it goes. Look at the circle. Half of it is pi. It's 180 degrees and we doing all right. A whole circle, that's 2 pi. 360 degrees. Ain't that fly? Next you're gonna learn how to convert. But let's go back to the hook first. Degrees are super fly, but radians, they make me want to cry. What are all these numbers and values of pi? Stick with us and we'll see what they're divisible by. So say you got a measurement and it's in degrees, and your teacher says, boy, convert this please.
Alright, so if you're going to convert an angle from degrees to radians, then all you're going to do is multiply the degrees by pi over 180 degrees. So, for example, if we have 30 degrees, I'm going to write the 30 degrees, and you're going to multiply it by pi over 180 degrees, which eventually is going to cancel out to be 30 pi over 180. Now, if you're good at math, you'll know that you can continue simplifying this. And eventually the 30 is going to cancel out with the 180. It's simply pi over 6. And that's how you're going to get your degree as a radian.
But what if it's in radians? What do you do? Stay right here and we'll teach you how to do that too.
Alright, now if we're going to convert an angle of a circle, but it's in radians and we want to convert it to degrees, it's basically the same thing as converting from degrees to radians, but opposite. So you're just going to grab the radian measure and you're going to multiply it by 180 over pi. So, an example. 7 pi over 6 as a radian measure, all you're going to do is multiply it by 180 over pi. Now, don't be intimidated because you can solve this. So, this is going to become 1260 pi over 6 pi. Now, like we know in math, you can continue simplifying this fraction. The pi's are going to cancel out and you can continue simplifying 1260 by 6, which is eventually going to become 210 degrees. And that's how you convert from radians to degrees.
Now I bet you're thinking, man, that's easy. I could do this in my sleepy. But that's not all, you ain't getting off yet. Coterminal angles are the next step. They share the same terminal side and they share the same initial side. There's a way to calculate them. Stick right there and we'll show you how to do it. Woo! You add or subtract 360 degrees from your angle measurement, simple as could be. And if it's a radian, add or subtract 2 pi. Here's a teacher to show you. You don't have to cry.
Good afternoon, class. Today, we're going to learn about how to calculate your coterminal angle. Now, if your angle measurement is given in degrees, what you're going to do to calculate your coterminal angle is add or subtract a multiple of 360 degrees. For example, to find the positive coterminal angle of 60 degrees, you're going to add 360 degrees to 60 degrees, which equals 420 degrees. This would be the positive coterminal angle for 60 degrees. Now what does this mean? This means that from your initial side, you will have to travel 420 degrees to reach the same terminal side. How about that? Now, what if you're asking me, Alex, I gotta find my negative coterminal angle as well. Well, we gotta show for you. This time you're gonna subtract a multiple of 360, or in this case, just 360. 60 degrees minus 360 degrees equals negative 300 degrees. This is your negative coterminal angle.
Degrees are super fly, but radians, they make me wanna cry. What are all these numbers and values of pi? Stick with us and we'll see what they're divisible by. Yeah. Alright, now that you know the basics, we're gonna take it up a notch and you have to face it. Next, we're gonna cover arc length. Do you think you have what it takes? Arc length is the measure of arc, which is part of the circumference of a circle. It isn't really super hard, so if you know your stuff and you're good at math.
So if we're trying to find the arc length of an angle, which is going to be S, this portion right here, what you're going to do is follow a simple formula that goes arc length is equal to radius times theta. Theta is going to be the angle.
You take a measure of an angle, but it's got to be in radians, so here's an example. Now you gotta multiply it by r. The math is sick like the rims on my car.
Alright, so now that we have our angle measure in radians, we're going to plug in the pi value of the calculator and solve the actual equation. So when you multiply 11 times the value of pi and divide it by 36, that's going to equal 0.96. And since this is equal to our theta value, we're going to plug it back into our equation and multiply by r, which in this case is 5. So 0.96 times 5 is going to be 4.80. And that's going to be our arc length.
The last thing you know about radians is that they can be used even more past your expectations. If you want to find the area of a sector, radians will help you do that too. Take your radians and square that thing, then multiply it by your angle in radians. After that, divide it by 2, and that's really all you have to do.
Hello again, class. Today we're going to learn the area of a sector, dog. Now, how this is going down, for real, is 1/2 your radius squared multiplied by theta, or the radian measure of your angle. Now, in order to find area of a sector, let's take our angle. This angle is 2 pi over 3 radians. So our theta equals 2 pi over 3. Our radius equals 6 centimeters. That's all you need, folks. Check it out. Now, you just plug it into your formula. Area equals 1/2 radius, area equals 1/2 6 squared times 2 pi over 3. Now all you're going to do is plug that into your handy dandy little calculator, and you get G. Willikers. Area equals 37.7 centimeters squared.
Pre-cal is my motivation. It leads me on the road to higher education. If I don't pass, I'll live on the street. So food for the mind, that's what I eat.
Some people say easy as pie. I just knocked over a glass of water. I say easy as radians. Get it?